Hey everybody. This week we are combining some of the topics we've just recently learned about. Specifically, we've talked about probability and then we've talked about counting things with the fundamental counting principle, with combinations, and with permutations. Well, we're going to combine counting and probability, and we're going to be determining probabilities using these counting methods. So, just a quick review of the formulas that we can use. So, in the videos I did last week, there's really two different options. You can use the formulas for permutations and combinations, or you can kind of just work it out, maybe by drawing a picture or just thinking about it. Whatever works for you. Hawks relies on the formulas a lot of time. So I'll definitely put some focus on the formulas. So the formula for combinations is n factorial divided by r factorial times n minus r factorial. And then the formula for permutations is n factorial divided by n minus r factorial. So, I mean, these formulas are very similar, right? It's just the combinations has this extra r factorial on the bottom. Okay, so let's go ahead and look at problem number 1. And when you are doing these problems, this is section 7.3 when you do the homework. The first thing you really want to think about is this a problem with combinations or is this a problem with permutations? So we're going to read this and then we'll try to figure out if it's permutations or combinations first. So a local pizza parlor has the following list of toppings available for selection. The parlor is running a special to encourage patrons to try new combinations of toppings. They list all possible 3-topping pizzas, 3 distinct toppings, on individual cards, and give away a free pizza every hour to a lucky winner. And then we have a table here of all the possible different pizza toppings. And we want to find the probability that the next winner randomly selects the card with the pizza containing green peppers, ham, and bacon. Okay. So as I said before, the first thing you want to really think about is this a combination problem or is this a permutation problem? So with combinations, remember, order does not matter. Whereas with permutations, order definitely matters. So if you think about, this is a problem about pizza toppings. When you put toppings on a pizza, does the order matter? And no, it doesn't. They want us to figure out the probability that we select a pizza with green peppers, ham, and bacon on it. Well, it doesn't really matter if I put the ham on first, then the bacon, then the green peppers. In the end, it's still one pizza with those 3 toppings. So this is definitely a combination problem, which means you're going to be either using the formula for combinations or just the method to figuring out the combination. Okay, so we want to figure out the probability that the winner randomly selects the card that has green peppers, ham, and bacon. So I'm going to put GP for green peppers, H for ham, and B for bacon. We want to figure out the probability that they select the card with these 3 toppings, or corresponding to the pizza that has these exact 3 toppings. So remember, with probability, it's a division problem. On top, you want the top number is what we're focusing on. What are we trying to figure out the probability of? And in this case, the top number is the number of ways we can choose a pizza with green peppers, bacon, and ham. It's not the same order as I listed over here because, again, order doesn't really matter. All right, we'll come back to that. The bottom number, then, is the total number of ways to create any 3-topping pizza. This is a problem about 3-topping pizzas, right? So the number on top is the number of ways to choose a pizza with those 3 exact toppings that we were looking for. The bottom number is the total number of ways to create a 3-topping pizza out of all the ingredients that they give us. So the number on the bottom is always going to be like the total, everything put together. The number on top is what we are looking for specifically. What are we trying to figure out the probability of? All right, so now we got to figure out these values. So, how many ways can we pick a pizza that has exactly green peppers, bacon, and ham? So, now remember, if I put green peppers on first, then the bacon, then the ham, that's the same thing as putting ham on first, then the bacon, then the green peppers. Or maybe we do bacon and then ham and then green peppers. These are not 3 separate pizzas. It's the same pizza, right? So when we think about the number of ways we can choose a pizza with these 3 toppings, there's only one way to do that. There is only one pizza that will have green peppers, bacon, and ham. Now, the bottom number is the number of ways to create a 3-topping pizza. So we don't care about what the toppings are specifically. It's just any 3 toppings. Up here, we knew exactly which toppings we were looking for, and there's only one way to create that type of pizza. On the bottom, we're looking at all possibilities. So you need to count up the total number of toppings we have, and notice that we have 4 rows and then 4 columns. So there's 16 different toppings if you multiply those together. So there's 16 available toppings, but we're only choosing 3 of those toppings for your pizza. And we're using the combination formula, so we would write this as 16, choose 3. Right? There's 16 toppings in total, but we only want 3. Okay, and that's the probability. Just the last little bit we have to do is actually simplify this problem. So just so these videos aren't 3 hours long, I'm just going to stick with the formulas. However, if you felt more comfortable with, kind of drawing a picture and working it out that way, then do that. But for right now, it just might be a little bit easier just to stick with the formulas. As long as you get the right answer in the end, right? That's all that really matters. Okay, so I'm going to kind of come over here to the side and do the work. So on top, number 1 is number 1. We don't have to simplify that. That's already done. But let's figure out this 16, choose 3. And if we plug that into the formula, we get 16 factorial over 3 factorial times 16 minus 3 factorial. So we get 16 factorial over 3 factorial times 13 factorial. So remember, we can peel numbers off of this 16 factorial until we hit 13 factorial, and then those will cancel out. So at least for right now, I'm going to write this out the long way. But we've done problems just like this last week, so you can check out those videos if you are confused. So yeah, we peeled off these numbers off of the 16 factorial till we got to 13 factorial because we can now cancel those out. And all we're left with to calculate is 16 times 15 times 14 divided by 3 factorial. That's 3 times 2 times 1. That's 6. And then if you pop this into a calculator, you should get 560. So again, what this means is out of the 16 toppings total, if we pick 3 toppings at a time, we can make a total of 560 different pizzas, where each pizza has a different set of toppings. All right, and our answer was 560 for that, so we just plug that in, 1 over 560. Hawks will allow you to type it in this way because this is reduced, or they'll ask you to put it in as a decimal, which you will get 0.00179. On the homework, they tell you to round to the nearest millionth. There we go. So that is 5 decimal places. So on some, if we have a long decimal for the probability, they want you to round to 5 decimal places. So this might already be rounded. This answer is already rounded. So this might have been an 8 and then some other numbers, but I went ahead and rounded it 5 decimal places. Okay, so let's do some more to kind of get the hang of this. So that was number 1. The chance out of all those 560 different types of pizza, the chance that you pick the card that corresponds exactly to a green pepper ham and bacon pizza is 1 out of 560, or definitely lower than 1%.